Did you ever wonder why the Earth has continents and ocean basins? It's like the Earth has these two different elevations. We've got these places called continents that stick up high out of the ocean, and then these places called ocean basins that are on average about 2.5 miles below the surface of the ocean. High places, low places. Why is that? The reason why we have continents that stick up out of the ocean and ocean basins that are deep below the ocean surface is because the outer part of the Earth is made of two kinds of crust, what we call continental crust and oceanic crust. On a sketch here on the board that shows the continental crust and the oceanic crust lying on the Earth's mantle. And one thing you can see on my sketch is that the continental crust is much thicker. It's about 22 miles thick on average, whereas the oceanic crust is the thinner crust. It's about 5 miles thick on average. Both kinds of crust lie in this very thick region of the Earth that's called the mantle. It goes about halfway down to the center of the Earth. There's another important difference between these two kinds of crust besides their thickness, and that's their density. The continental crust is a lighter, less dense crust. It has a density of about 2.7 grams per cubic centimeter, whereas the oceanic crust is a heavier, denser crust, about 3 grams per cubic centimeter. In other words, it's about 10% denser than the continental crust. I've got here in my hand a piece of granite. Granite is the main rock of the continental crust. You can see it's kind of a light-colored rock, and you can probably see the individual crystals in the rock. This rock is actually a fairly light or less dense rock. In comparison, we've got this piece of basalt from the ocean floor, and this is the main rock of the oceanic crust. You can see it's dark in color, and unlike the granite, it's got much smaller crystals. As I run my fingers over the surface, I can feel kind of a sandpapery texture, telling me there are crystals in there, but the crystals are much smaller. And this forms from lava erupting at the mid-ocean ridges and the seafloor spreading. It's the most common rock on the surface of the Earth. It makes up the oceanic crust. You can see here I've got a piece of redwood, and you can see it's a fairly thick piece of wood. Redwood is also a fairly light, low-density wood. This is like the continental crust, thick, relatively low-density or light rock. The maple here is like the oceanic crust. It's a thinner block of wood, and it's also a hardwood, and so it's denser, it's heavier than the redwood. And when I float my continental crust in the mantle, you can see that it sticks up pretty high, and when I float my oceanic crust in the mantle, you can see that it sits down pretty low. So the thick, light continental crust sticks up high and forms dry land. The thin, heavy oceanic crust sits down low, about 2.5 miles below the ocean surface. If we didn't have any of this stuff on Earth, continental crust, rock like granite and its relatives, there would hardly be any dry land on Earth. We'd live on a planet that was maybe just a few islands. Otherwise, it would be covered with water. So every day I want you to thank the thick, light continental crust for sticking up out of the ocean and making dry land, because otherwise we wouldn't be here talking about it.